I'm going to suggest that unless you have your truth functions memorized, you go grab your chapter 4.3 handout. That's the handout that has the truth tables for our 5 operators. All right, guess what you get to do? You get to see if you can deduce any logically necessary truth values for these 5 statements given the assumed truth values that are identified here. All right, so for example, in this first statement, we're being told, consider tilde true. All right, if you're considering tilde to be true, can you deduce the truth value for the H, the wedge, or the B? Or consider this statement here. You're being told that this horseshoe is true, but R is false. Given just that information, can you deduce the truth value for Q, or for the dot, or for S? All right, so go ahead and get your handouts handy and pause your video. And when you're ready to check your work, go ahead and restart it. Okay, so this first statement, we're being told that the tilde is true. And if that's the case, then we can determine the truth value of this wedge here, because this tilde is operating on the main operator in parentheses here, wedge, and we know that it's going to have an opposite truth value. So if tilde is true, the wedge has to be false. And now we can look at our disjunction truth table, and we can see that, well, if wedge is false, then that means that what appears on the left-hand side and the right-hand side have to also both be false. So I was able to determine the truth value for H, for wedge, and for B just knowing that the tilde was considered true. All right, now look at the second statement here. We've got a horseshoe, and we know that the horseshoe is being told is true, but R is false. Now, the truth value of this horseshoe being true means that we've got to determine the truth value of this statement here in parentheses before we can determine the truth value of true. So we consult our conjunction table, and we see that anytime either or both sides of the dot are false, the dot is false. S could be true or false. We don't know, so that remains unidentified. But we know the truth value now of the right-hand side of the horseshoe is false. And we can also see here that the only way for this horseshoe to be true when the right-hand side is false is for the left-hand side to also be false. Okay, so we know the value of Q. All right, now let's look at this one. We've got another horseshoe statement, and we're told that K is true, the horseshoe is false, and this S here in parentheses is false. Okay, we know that for a conditional to be false, when the left-hand side is true, the right-hand side has to be false, and the right-hand side's the main operator here is that tilde. So we know that tilde has to be false. That's the only way that the horseshoe can be false when the left-hand side is true. Now, this tilde outside of parentheses is going to operate on this triple bar in parentheses. So if the tilde is true, we know that the triple bar is if the tilde is false, we know that the triple bar has to be true. We also know from our biconditional truth table that the triple bar can be true only when the sides have matching truth values. So if S is false, M has to also be false. That would make the triple bar true, which would make the tilde false, which would make the horseshoe false. All right, now we'll look at this one. Being told A is false, wedge is true. We know that in a disjunctive statement, in order for the wedge to be true, one or both sides have to be true. And we're already told that A is a false statement. So that means that tilde here has to be true. Now, if tilde on the outside of parentheses is true, then that means the operator it operates on inside parentheses has to have the opposite truth value, which would be false. And we know that there's different ways that this dot can be false. All it takes is for one side or the other to be false, or both. And we don't have any way to know what the case is here. So all the other truth values remain unknown to us. But we were able to determine the truth value of this tilde and that dot. Okay? And finally, we have this statement here where we're told the triple bar is false and R is false. Okay, we look at our rule for biconditionals, and we know that biconditionals are false anytime the sides have opposite truth values. Okay, so anytime the sides of a triple bar have matching truth values, the triple bar is true. But here we're being told it's false, and so if the right side is false, that means that the left side has to be true. And the main operator on the left-hand side is this tilde. And if tilde N is true, N's got to be false. All right?